Okay, guys, so today we're doing midpoint and partitioning a line segment. Partitioning a line segment is where you find the location of a point that's not in the middle. So what we've been doing is finding a point that is in the middle. That's what we did the other day when we were finding the average. So now we're just going to find about if it's not in the middle. So we're going to find one that is in the middle. So we're going to find one that is in the middle, and then we're going to find one that's not in the middle. All right. For some reason, this thing is really struggling to give me the color ink that I want. All right, so here we go. All right, midpoint by definition, okay? It is a point on a line segment that divides it into two equal, all right, and here we go, already off to a great start, into two equal parts. We'll just put the symbol, all right? So two equal parts, and if you need the word, equal, two equal parts. It is the halfway point. Use the tick marks to show both parts are equal. So if they have those matching marks, that means they're equal. Also remember, this is the same thing as finding the average. So finding the average of two points. Ooh, look like a kindergartner. All right, so here we go. The midpoint on a number line. So just starting out with a number line, it's super, super easy. You just find the space, okay? So if we have the endpoints of CD, so if we're at -3 and 5, and we're going to find the midpoint, so count your spaces, 1, 2, 3, 4, 5, 6, 7, 8. So if 8 is the total distance, then 4 would be halfway. So 1, 2, 3, 4. That would be. So what you do on a number line, count it up. The formula says to take the two numbers, so -3 plus 5, and divide by 2. So -3 plus 5 is the same thing as 5 minus 3, which is 2. And 2 divided by 2 is 1. So that is the location of your midpoint. Another formula is part equals part. So last lecture we talked about part plus part equals whole. Well, if those two parts are equal, then you can set them equal to each other. And these little matching tick marks right here are what's telling us that these two parts are equal. So your midpoint is pretty much where your equal sign is going to go. So if I were to set these two equal, so 4x minus 1 equals 3x plus 3. So we do our line. So if I subtract 3x from both sides, I get x minus 1 equals 3, and then add this 1 to both sides, x equals 4. So they want me to find the length of VM. So they want me to find this length right here. So 4 times 4 minus 1. So 16 minus 1 is 15. So I would say VM equals 15. And then we would have our answer there. All right. Now, the midpoint on a coordinate plane. This is where we did that warm-up the other day. This is the actual formula. So you add your x's and divide by 2, and you add your y's and divide by 2. But if you remember, we wrote them by stacking those 2 points and going through it that way. So if I wanted to, if it tells me the endpoints, so they're telling me the endpoints, and they said to find the midpoint, then I'm going to take these 2 points right here, so 1, -3, plus -5, 2. So I'm going to add them together. I'm going to add the x's together, just like it says to do here. Add your x's. So 1 plus -5 is -4. -3 plus 2 is -1. And then it says to divide by 2. So now I'm going to divide the whole thing by 2. So I've got -4 divided by 2 is -2. And -1 divided by 2 is -1 over 2. Remember, just leave it as a fraction. No sense in doing anything extra. And this is your midpoint. This is your midpoint. You are done. That is the answer. Okay. Now, if we're on a coordinate plane over here, we can plot the points so we can kind of see what's going on. So the midpoint of JK is 2, 1. So of the midpoint of JK, so think about this. You got a line JK, and they're telling you, hey, this is your midpoint. This right here is your midpoint. One of the ends is here, and they want you to find the other end. So let's plot this. So 2, 1. So that's the middle. And 1, 4, that is the beginning. So I need to know, looking at this, if this is the middle, then I know the other end has to be here somewhere. So what I'm going to do is I'm going to start here. I'm going to go 1, 2, 3 over 1. So I'm going to go 1, 2, 3 over 1. So point K should be at 3, -2. So that's where it's at. Now here's the catch. What if you don't have a number line? So again, just like I did here with the stacks, I'm going to do this. So I know that I've got J, M, and K. J is at 1, 4. M is at 2, 1. I need to find K. So what I'm going to do here is I'm going to think to myself, how do I go from 1 to 2? So to go from 1 to 2, I have to add 1. So I'm going to change colors. So if I have to add 1 to get to 2, I'm going to add 1 again, and I get 3, which is what I got here. How do you go from 4 to 1? Well, if I'm at 4 and I get to 1, I had to take 3 away. So I'm going to take 3 away again. 1 minus 3 is -2. And again, there's your answer. So you got the answer 2 separate ways. Okay, so I like the stacking the points and doing it that way. And whatever I did to this point right here, I have to do to this one here, because this is the middle. All right. Now, segment bisectors. Bisector. Bisector means you're cutting something in half. All right, just like whenever you dissect in science, you're cutting. Bisect means you're cutting in half. So a point, ray, line segment, or a plane that intersects a segment at its midpoint. Okay, so anything that cuts something into 2 equal pieces, it's a segment bisector. Okay, so what I see here is that this piece AM and this piece MB have the same tick mark. So that means 5 is equal to X. So that means if this side is 5, then this side is also 5. Okay, so down here, so they're saying the segment bisector. The segment bisector is this piece right here. So this is MC, and it's a ray. So ray MC is the bisector. This is what's cutting it in half. Let me make sure I don't cover up the arrows there. So MC is my bisector, and the length of AB, the whole entire thing. So remember, part plus part equals whole. So since 5 is equal to X, I know 5 plus 5 is equal to 10. So AB is 10. And I know that's a super easy example, but you do them the same. In this picture here, the segment bisector is this line. And I know it's a line because it has arrows on the end. So PQ is my bisector. So line PQ, or you might want to call it QP, whichever way, it doesn't matter. Whichever way you like to write it. Lines have no relevance. Since they have the same tick marks here, that means they are equal. So that means 9x plus 18 is equal to 12x minus 21. So now do y'all see why I told you if you cannot do the algebra, how this is going to be painful? So I'm going to subtract the 9x because it's smaller. So I'm going to subtract 9x. So I get 18 equals 3x minus 21. And then I'm going to add this 21 over here. So that's 39 equals 3x. Those cancel. And then I'm going to divide by 3. So I get that x is 39 divided by 3 is 13. So I know x is 13, but they want me to find the length of AC, which is this piece right here from A to C. So that means 9 times 13 plus 18. So 9 times 13 is 117 plus 18. So that is 135. So AC is 135. Okay, AC is 135. All right. Remember, you can always push pause when you need time to write something down. All right, the last part of our lesson here is what's called partitioning a segment. So the steps are to find the distance, multiply by the fraction, add to a smaller number. So this is how I do this. So it says to find x. So they want me to find where x is located. Well, clearly there's not an x on my grid because I have to find it. So I want to go from A to F. Okay. So the distance from A to F. So remember, we did distance the other day. So the distance is -7 minus 5. So that's -12. So the distance is 12. So point X is located. So you found your distance, right? So you're going to take your starting point. So take your starting point right here, -7, plus a sixth of the distance. So 1/6 of the distance. So 1/6 times 12. So always think of it as start plus your fraction times your distance. I'm going to need to move this out of the way because I did not plan this very well. So there we go. So I'll move it over there. So now I know that x is located at -7. 1 times 12 is 12. 12 divided by 6 is 2. So -7 plus 2 is -5. So I know that at -5, which is right here, this is where point X is at. So point X is located at -5. All right, so we found our distance. We multiplied that by the fraction, distance times the fraction. We added it to the smaller number. So it's all written out right there. So let's try one more, and then we are done. So find the coordinate of point P of CF. So C to F, that partitions it in a ratio of 2 to 1. So first of all, we got to take this 2 to 1, and we have to turn it into a fraction. The first number is 2, so your 2 is going to be your numerator. 2 plus 1 is 3, so that's your denominator. So first thing we're going to do is find your distance. So the distance is going to be -4 minus 5. So from -4 to 5, from C to F. So that's -9. The absolute value of -9 is 9. So my distance is 9. So now what I'm going to do is I'm going to find point P. So now point P is located starting at C. So -4 plus my fraction, 2/3, times my distance. So -4 plus 2 times 9 is 18. 18 divided by 3 is 6. Negative 4 plus 6, it's the same thing as 6 minus 4. So point P is located at 2. So point P is right here. So that is where point P is located. It's located at E. All right, so that's it. The end. Short and sweet. And I will see you guys next class. Have a good one.